In today's lesson, we're going to be talking about exponential and logarithmic equations. We've been going over and reminding ourselves about some of our exponential and logarithmic graphs, and in our last lesson, we learned about our properties. And so now we're going to use those ideas to help us solve equations. So the first two things that we're going to want to talk about are the one-to-one property and the inverse property. And these are going to help us solve. So our one-to-one property states that if I have b to the x and it equals b to the y, this can happen if and only if x equals y. Meaning that if my bases are the same, the only way that those two things can be equal is if my exponents are also the same. And we also have a property with our logs. So if I have log base b of x equals log base b of y, likewise, this can happen if and only if x equals y. Now, our inverse property we've briefly talked about. It tells us that if I have b raised to the power of log base b of x, it's going to equal just x. Also, if we have log base b of b to the x, it will also equal x. Because our logarithms and exponentials are inverses, if we take one of the other, then they're going to undo each other, and we're just left with x. Alright, so before we get started, some tips for solving. We want to check a couple of things. First, we want to rewrite using the 1-to-1 property. If we can't do that, then our next goal is to rewrite using the inverse property. And also, we always want to check for extraneous. So remember that just means extra. Solutions. Because sometimes we'll have solutions that don't actually make our original equation work. And we need to make sure that we don't include those in our solution sets. So on problem A, notice that we have e to the negative x squared equals e to the negative 3x minus 4. Hopefully we notice right off the bat that our bases are the same. Because of that, we can use our one-to-one property, and we know that the exponents will have to be equal. So now we have a quadratic. So I'm going to move my x squared over. Now it's set equal to 0. We can factor and solve. So we're looking for what multiplies together to give us negative 4. That adds together to give us negative 3. Well, that's going to be negative 4 and positive 1. So we get x equals 4 and negative 1. And then remember, we want to check our solutions. We can just do a visual check in this case. We want to make sure that it's not going to cause a domain error. But because we're plugging into exponents in this case, we can look and we can kind of see that they're both going to work. So those would be our answers. So part B, we have 3 times 2 to the x equals 42. So our first goal is going to try and be to use our one-to-one property, but in order to be able to do that, we need whatever's being raised to a power to be by itself. So we would need to divide by 3 on both sides, and so we get 14. Now this one's a little bit different than our last one because 14 isn't already written as a base of 2. But if we can write it as a base of 2, that's what we want to do. But if we think about it, well, 2 to the first is 2, 2 squared is 4, 2 to the third is 8, and then 2 to the fourth is going to be 16. Now, that 14 is not included, so that means that we can't use our one-to-one property. So then, like we said, our next step is to try and rewrite using our inverse property. So basically what we're going to do is we're going to take log base 2 of both sides. Just like we can subtract 2 from both sides or add 2 to both sides, as long as we do it to both sides, we can take log base 2 of both sides. Now the reason we want to do this is because notice on the left hand side, using our inverse property, that's just going to be x. So then we're left with x equals log base 2 of 14. Now in this case, it asks us to round the result to 3 decimal places. If I asked you for the exact answer, log base 2 of 14 would be your answer. If it asks you to round, then you would need to plug that into your calculator. If you're using a TI-84 or above, you can go into your math menu and go to where it says log base, and you're able to plug in a separate base. If you don't have a TI-84 or above, you're just using a scientific calculator, then you would just want to plug in log 14 divided by log 2. So using that change of base formula to evaluate. Whichever one we use, we should get the same thing. It's going to be 3.807. And again, doing a visual check, I only have one answer in this case, so it works, and that is our final solution. So next up, we're looking at still an exponential equation, and we have e's this time. So again, remember, we want to always try and rewrite with a base first. So in this case, notice that our e to the x isn't by itself, so we need to move our 5 over, and we get e to the x equals 55. Now, because e is an irrational number, we're not going to be able to rewrite 55 as a base of e. So we're going to need to take the natural log of both sides. So remember that a log with a base of e is going to be the natural log. So our log has a base of e, what's on the inside has a base of e. Using my inverse property, they reduce each other, and I'm left with x equals the natural log of 55. Again, they ask us to round to the 3 decimal places, so we can plug that into our calculator, and we get 4.007. Alright, now this next one looks a little bit more complicated, but it's not awful. So again, remember, we always want to try and move the stuff away from whatever's being raised to the power. So we want to add 4, and we get 15, then divide by 2, and we get 15 halves. Then we're going to take log base 3 of both sides. Now this one's a little bit different because whenever my log and my base reduce with each other, I'm still just left with the exponent, but notice this time that we have some other stuff in our exponent besides just the variable. So we still need to solve for t. So we would want to add 5 and then divide by 2. But be careful, because we've already taken the log of both sides, that plus 5 and that divided by 2 are outside of our logarithm. So when you plug that into your calculator, you need to make sure that you end your parentheses after the 15 divided by 2. Because once we do that, we should get 3.417 approximately. Alright, on our next one. So, on part A, notice that we have a natural log this time, and we have the natural log equals 2. Now, notice I can't use my one-to-one property, so we want to use our inverse property. This time, because we already have a logarithm, we want to put both sides as a power of whatever our base of our logarithm is. So in this case, we have a natural log, so our base is e. So we're going to put both sides as the powers of e's. Because once we do that, notice that our e and our natural log reduce, so we're just left with x, and then we get e squared. Again, in your scientific calculator, you have an e button, so you can use that, raise it to the second power, and we get a decimal approximation of 7.389. Now on our next one, notice that we do have logs on both sides. My bases are the same, so we can go ahead and use that one-to-one property and set our insides equal to each other. And then we just solve like we would normally solve. We subtract x, add 1, and we get x equals 2. So then we need to double check that when we plug back in, that we're not going to get negatives inside of our zeros or negatives inside of our exponents, inside of our logarithms. So we would have 5 times 2 is 10, 10 minus 1 is 9, and then 2 plus 7 is also 9. So it works out, so that's our answer. And then the same thing with our x over here, but it's already positive, so we knew that that would be our answer. Alright, so on our next one, again, just like with our exponentials, before we try and rewrite things, our logarithm has to be by itself. So in this case, we would need to subtract 5, we get negative 1, divide by 2, and we get negative 1/2. So now that our natural log is by itself, we don't have logs on both sides, so we know we can't use our one-to-one property. So we're going to put both sides as powers of e again. My e and my natural log reduce, so we're left with x, and we get e to the negative 1/2. Again, plugging that into our handy-dandy calculator, we get 0.607. So let's try one last problem. So it says solve log of 5x plus log of x minus 1 equals 2. So notice that we have two logarithms, but we can't set the insides equal to each other because they're on the same side. But also notice that even if we moved one of those to the other side, we would still have that 2 there. And so that's going to get in the way of being able to set them equal to each other. However, notice that we have two logs and there's an addition sign in between them. So thinking back to our last lesson, we should recall that we can actually combine those to be one logarithm and use multiplication. So we would get log of 5x squared minus 5x equals 2. Then remember that if I don't have a base, it's an understood base of 10. So we're going to get 5x squared minus 5x equals 10 squared, which reduces to I'm going to go ahead and move the 100 over by subtraction. And I notice that everything can be divided by 5. So I'm going to go ahead and do that. Because now when we factor it, it makes it a little bit easier. We're looking for what two things multiply together to give us negative 20. That add together to give us a negative 1. So that's going to be positive 4 and negative 5. So notice that when we solve, we're going to get x equals negative 4 and 5. However, be careful, because notice if I was to go in and plug that 4 in, I would have log of negative 20, because negative 4 times 5 is negative 20, plus log of negative 5 equals 2. And that is a big no-no. We're not allowed to have negatives inside of our logarithm. Now, if we did the same thing with our 5, we would get log of 25 plus log of 4 equals 2. And that's fine. So that 5 is going to be our only answer. And that's what we meant by checking for extraneous solutions. Now be careful, because it's not necessarily always going to be the positive number that makes it work and the negative number that doesn't work. It's going to be whatever makes the inside negative. So if for some reason we had like log of negative 5x, well, now notice that the negative 4 would make the inside positive, but the 5 would make the inside negative. So in that case, they would actually be the opposites.